Okay, so this video is on the force of gravity or weight. So far, we've just talked about Newton's three laws a little bit. We've talked about Newton's first law. It says that objects in motion stay in motion unless they're acted on by an outside force. And it's also called the law of inertia. And before we move into Newton's second law, we need to talk about the force of gravity, which is, another name for that is weight. You know, when you weigh yourself, find your weight, you are finding the force of gravity that is different than from mass. Now, force, and you should have already written this down on the guided notes page, but a force is any push or pull, and the units for force are newtons. So Isaac Newton was the one who came up with Newton's three laws of motion, and we credit him with naming a unit after him. Now there's four fundamental forces that make up all the forces in the universe. The first one is the gravitational force, and I think we all know what gravity is. That's the force that attracts two objects. It keeps the planets and revolving around the sun, and the moon's revolving around the planets. It also is the force the Earth attracts objects to. If you were to jump off of a building, the Earth attracts you, you're going to fall. All right, so that's what gravity is. So electromagnetic force has to do with electrons, and then magnetism also. The strong nuclear force and the weak nuclear force deal with atoms. The strong nuclear force is what keeps the electrons and the protons and all that together in atoms. And then the weak nuclear force has to do with nuclear forces that allow atoms to break down and like radioactive and where they decay and stuff. But you just need to know these four fundamental forces, and then within that we're going to talk about other forces like contact forces and non-contact forces in a few days. So the force of gravity, any two objects will feel a force of attraction that depends on their masses and distance apart. So if you are any two people have a force of gravity between them, you don't really feel that because it's so small. Depends on your distance and also the masses, but it's there. All right, mass is measured in kilograms. It's not grams. If you ever we'd ever do any problems where it has a mass in grams, you would need to convert it to kilograms. You divide by 1,000. In physics, we deal with kilograms when we're talking about masses. And it's the amount of matter in an object. It doesn't matter if you on Earth you have a certain mass. If you go to the moon, your mass is going to be the same. You cannot change the amount of matter that's in your object and in your body. That all depends on, all the atoms that make up your body, and that doesn't change if you go somewhere else in the universe. What does change, though, is weight, which is really what we're calling the force of gravity, and it's the amount of gravitational force felt by an object. It's measured in newtons. If you go to the moon, you wonder why are people in a space shuttle, or when they get to the moon, and you see the astronauts floating around. It's because the amount of gravity that's on the moon is less than it is on Earth. So you would weigh less. Especially the moon has about 1/6 the amount of gravity that Earth has. You would weigh about 1/6 the amount on the moon. All right, and that's measured in newtons. And mass is constant throughout the universe, whereas weight changes depending on where you are. And we're going to look at that. Okay, the formula for force of gravity is Fg equals mg. If you notice so far in physics, we deal with formulas. We take mathematical equations to describe things that happen in the natural universe. Everything is based on math and numbers. So we can find the force of gravity, and again, this force of gravity is the same thing as weight. You know, we could write this equation as weight equals m times g also. All right, our mass, our m is our mass, it's in kilograms. G is acceleration due to gravity. So a lot of times people want to say, they see that G and they want to say, oh, that's gravity. No, that's acceleration due to gravity. What that is if I was to jump off a building, I'm going to accelerate downward at 9.8 meters per second squared. That's what it is on Earth. That's how, that's acceleration that the Earth is pulling down on me with. It's not the force of gravity, it's not gravity, because the force of gravity is Fg. All right? And but everything would fall. If you drop, if you dropped a bowling ball and a tennis ball off a building, they're going to fall at the same rate. They're going to hit at the same time if you drop them exactly the same time, because the acceleration due to gravity is 9.8 meters per second squared on Earth, and they would hit at exactly the same time. And then the last, force of gravity. But you could write this equation, W equals M times G. Just know that when I mention force of gravity, I'm talking about weight. Now, G, the acceleration due to gravity, varies depending on the size of the planet and the distance to the object. So the smaller the planet, if it's 9.8 on Earth, it's going to be smaller. If you notice on Earth, it is 9.8. You need to memorize that number. All the other times, a lot of times we have these problems. If you need a G value, I'll give it to you in the problem. But if we're talking about Earth, I expect you to memorize that number. And on the moon, since it's smaller than the Earth, the G value is smaller. On Jupiter, it's larger than Earth. It's 24.5 meters per second squared. And then the Sun, since it's larger than all of them, it's 274 meters per second squared. All right, so let's look at some problems. Now you should have written down on the left these values right here, these G values, and let's look at how we would use those to find our weight. Now, my example mass is 150 kilograms. Just make sure that if I was to give you grams, you convert that to kilograms, which you would divide by 1,000 and move your decimal 3 places to the left. All right, so my weight on Earth would be, I'd plug in, Fg is my weight. I would plug in my mass. It's 150, multiply it by my G value, acceleration due to gravity on Earth, which is 9.8. And then that would give me 1,470. My units will be newtons. Make sure I did that right. Didn't punch in something wrong. Yeah, that's correct. Now I want to find my weight on the moon. So again, Fg equals mg, so I could just say 150 times 1.6. It would be 240 newtons. And then my weight on Jupiter, where G is equal to 24.5. Take 150 times that. And I would get 3,675 newtons. So if you notice, my mass would be 150 on all three places, but my weight would change. Okay, moving on to the next page. If we look at our first example problem, say a person weighs 300 newtons. What is the mass of the person? And we're going to be using the same equation on all these problems. Fg, force of gravity, which is the same as weight, equals mass times g. Now, I'll go through the problem. I'm going to underline what I need to, the numbers that are important. And it says a person weighs 300 newtons. What does it tell me there? It's giving me a Fg value, weight. What is the mass of the person? Now I should have specified where they're at, so you can change that. What is the mass of the person on Earth? So you always need to pay close attention about where the problem is talking about. Is it talking about Earth or some other planet? If I give you a planet that's not one of the ones mentioned over there, then I'll have to give you the acceleration due to gravity for you to solve these problems. So I'm looking for mass, and since I know on Earth, and I know that my Fg is equal to 300 newtons, I'm going to write down my givens. I'm going to write down my unknowns. So on Earth, I know that G is equal to 9.8 meters per second squared, and I'm looking for a mass. And my mass is going to be a question mark. It's my unknown, and it's going to be measured in kilograms. Next, I want to write down the equation I'm going to use for all these problems. It's going to be this one. Then I want to plug in and solve. So for Fg, that's 300 equals my mass times 9.8. Alright, so when I get to this, how do I solve for m? M is my x. Instead of putting an x in there, I'm going to leave it as m, because in physics we like to leave things as symbols for what they are. You know, it's just algebra is all we're doing, though. It's not any different. Now, so if I need to divide both sides by 9.8, cancels on this side. So it ends up being mass is equal to 300 divided by 9.8. And on all these problems, you can round your answers to one decimal place. Bring up my calculator. And that gives me, and you can round these answers to one, like I said, one decimal place, 30.6. And then my units for mass is kilograms. So pretty much, if I'm finding mass, I am dividing by, I'm taking my weight and dividing by the acceleration due to gravity. So, next problem. Asking what is the weight? I want to know the weight of a 740 kilogram object. That's telling me mass is in kilograms and it's on Earth. So write down my knowns. This is 740 kilograms on Earth. So it's telling me that G is going to be 9.8 meters per second squared. And then I'm looking for weight, which is Fg. It's my question mark. My units are going to be newtons. That's my givens and unknowns. And I'm going to write down the equation I'm going to use. Fg, force of gravity, equals mass times acceleration due to gravity. I'm going to plug in my weight is my unknown, so I'm going to leave it as Fg equals my mass was 740 times my G value on Earth, which is 9.8. So when I work that out, I get 7,252, and like I said, my units will be newtons. Alright, so if I'm finding weight or force of gravity, I'm multiplying mass times the acceleration due to gravity. If I'm finding mass, I'm taking my force of gravity and dividing by 9.8. Let's look at this last one. It says a 54 Newton object. And what is that 54 Newtons telling me? It's telling me my weight or my force of gravity. It has a mass of 22 kilograms. That's mass. It's on planet X. What is the acceleration due to gravity, my G value on planet X? So I'm going to write down my givens. Force of gravity is 54 newtons. Mass is 22 kilograms. I'm looking for the acceleration due to gravity, which is G. It's going to be my question mark, and the units for that are meters per second squared. Now, one other thing though, sometimes the units can be in meters per second squared, and another way of showing that units are Newton kilograms, newtons per kilogram. Either one of those units are fine. That's the same thing as, in this case, meters per second squared. So if you see that Newton kilograms, just know that same thing as meters per second squared. So next I'm going to write my equation. Fg equals m times g. Plug in my Fg was 54 and equals my mass, which was 22, times g. If I want to solve for g, I need to divide both sides by 22. And then g is going to end up being 54 divided by 22. Like I said, you could round these one decimal place, 2.45. I would round up to 2.5. My units, meters per second squared. So you always need to remember the equation, because instead of trying to memorize, well, if I'm going from mass to weight, I need to multiply, or I need to divide. If I'm trying to find weight, I take my mass and multiply it by g. There's no use in memorizing all that. Remember your equation, plug your numbers in, and then do the appropriate algebra, and that's all there is to these problems right here. Now, right now, you should work these 6 problems. We will have a quiz on these types of problems in a few days. And you'll just be able to use the equation Fg equals mg, and you'll need to memorize this number right here. Any other G values you need for other planets, I'll give them to you in the problem.